So the story of Uncle Tungsten talks about the boyhood of this British famous neurologist named Oliver Sacks. Now, even though he did not pursue a degree in chemistry, it did intrigue him when he was little. And one person who really helped that was his Uncle Abe, or Uncle Tungsten, which really got him into chemistry. Now, so the point of these videos is to sort of summarize the book and sort of expand on the parts of learning the chemistry part of it. So I try to take this book and I try to summarize each chapter. And so, so this chapter, I am talking about the chapter called The Land of Stibnite. Now, just a little beginning of the book. Of the chapter, it talks about how young Oliver, when he was little, he was very scared-ish after the war, but before he sort of picked on fights, he was a little bit more confident, and to compensate with this, he tried doing Boy Scouts. Now, in Boy Scouts, you have to learn how to be resourceful and sort of not ask many questions and try to be responsible by yourself. So one time he had to make dampers for this little meeting, and dampers are like these really hard bread. Dampers require usually like flour and just a little bit of seasoning, and you bake them and they're good to go. And one day when he was making them, he realized there was no more flour. Now, instead of going out to buy from the store, he noticed that there was cement left on the side of the road, and he sort of thought through this little child brain process that, hey, this is a good idea. What could go wrong? And eventually, that's when someone's tooth cracked, and that's how he got kicked out of Boy Scouts. Now moving towards the science part. So, first it talks about library. It talks about the library when he was little, because during his school, they sort of worked on the classics, and they didn't work much on science. So for this reason, he sort of went to the library to compensate for this, and he would love to read. He would usually skim, do whatever he wanted, really. And he would divide his free time in between library and working with his uncle. Then later, it talks about the museums that he visited. So in the museums, he noticed one time he went was this giant pile of this like crystal looking mineral called stibnite. Now, he was trying to wonder, oh wait, where the heck is this from, right? And then he realized it's from this place called Japan. And so he kind of wished that he wanted to go to Japan, and that's sort of like the title, The Land of Stibnite. So, and then there was also some other things. For example, there was galena, which had sort of like cubic forms, some cubic shapes. And this was because Uncle Tungsten said that it's because of its chemical composition. The chemical bonds made to create galena were sort of in a cubic shape. So even if you were to look with the magnifying glass even further, all you would see would just be more cubes. And this was probably a similar case with stibnite, because stibnite is also sort of like a rectangular shape. So maybe the chemical composition is very similar as well. And then he starts talking about the names of minerals. So the names of minerals usually come from the people who discovered them, like scheelite, probably discovered from this guy named Scheel. Bunsenite, this guy just named Bunsen, probably the same guy who discovered Bunsen burner, who made the Bunsen burner. And Crooksite, probably this guy named Crooks. And usually it was because once the people have discovered it, they didn't really know what to name it, so they thought they can take the humble decision of naming it after themselves. Then he starts talking about the origins of elements. Now, they're not very similar, even though there are some elements named after people, such as Einsteinium, but Einstein did not discover Einsteinium. But usually they're usually Greek, and most of the time have their Greek names usually have something to do with the properties of the specific element, such as tantalum. Now, tantalum is named after this Greek guy named Tantalus, who was the favorite of the gods, but he cooked his son once, and he served it to the gods as some stew. And when he went to hell, he had the curse that he was not able to drink water. Whenever he would try to bend down at a pond or bend down to drink water, the water would sort of retreat from him. So he was always thirsty, never allowed to drink water. And this is sort of similar with tantalum, because tantalum sort of could not drink water or could not be dissolved into acids. And then there's niobium, which, if you are following along with the Greek pattern, Niobe was the daughter of Tantalus, which is why they were always found together. This was actually a similar case with tungsten and molybdenum. And let me explain with that. Because these two elements were so similar, and if I pull out a periodic table, you can see that tungsten and molybdenum are literally like top and bottom from each other. And actually niobium and tantalum are also very similar, because they're also right above each other. These two are always found together. These two are always found together. And they're so similar that in the minerals that they're discovered in, whenever you try cutting this mineral in half, you don't actually get the same amount of percent of each element. For example, if you try cutting it in half, you might get like 99%, or in this case 55% of tungsten, but 45% of molybdenum. And the other half is 55% molybdenum and 45% tungsten. Now, why is this? Because if you look deep inside the atoms, in their structures, usually since each atom is so similar, they can literally just swap with each other whenever they pleased. They can literally just swap places with each other. And then he starts talking about his experiments that he did with these minerals. So he started thinking about how the buoyancy of each mineral. And he would have to use sort of heavy liquids, such as perhaps mercury or gallium, to find the buoyancies. Now, you're probably going to ask me, why do you need that? Why can't you just use water? Well, you have to think about it. If you use water and you put rocks in it, and now buoyancy is the ability to float in liquids. Usually, if you try getting these small minerals, most likely they would go to the bottom instead of floating instead. But if you got like gallium instead, some of them might float on the top of these, even though the others would fall down onto the bottom and sink. Or if you used mercury, where some of them might even go even farther down, or some of them would still float, even more would float, because perhaps mercury is even heavier than whatever mineral that they're trying to put on pond. And this sort of gives him some ideas what he would do, because when he was little, even though he would enjoy doing these little experiments, he was quite a shy kid, like I said in the beginning of the book. And how he overcame these things was he would show people what cool things he would do with these experiments, such as he would take this little bottle of what looked like water but was really a clarity solution, and he would give it to someone, and he would try seeing how heavy the bottle was with each person, how astoundingly heavy it was compared to a normal bottle of water. Or he would get this little spoon of gallium, because if you know about gallium, gallium is a liquid at room temperature. It's a transition metal. Actually, no, it's a post-transition metal. And what you can do with it is that you can find a mold for a spoon. You can just get like some Play-Doh. You can put a spoon in it, wrap it around, cool it so the Play-Doh is harder, bake it. Then you can like cut a hole in the Play-Doh, open it up, take out the spoon, and maybe pour some gallium into it. And once you pour some gallium, you can freeze that. And once it comes out, it's just like a hard, solid spoon. And what a little cheat that they would do with the guests is that they would try putting it, they would give it to them to stir their tea. And with one tea sweep, because the tea is so hot, it would instantly disappear the spoon. And these were the things that sort of made him a little bit more confident. And that is the end of the video. I hope you enjoyed.